In the realm of programming, data structures are fundamental. They are the backbone of any software application, providing the means to store, organize, and manage data efficiently. Without them, even the simplest tasks would become cumbersome and complex. They provide organized ways to store and manage data, making it easier to work with. Imagine trying to keep track of thousands of pieces of information without a system in place. Data structures offer that system, enabling programmers to handle data logically and systematically. Python, a versatile and beginner-friendly language, offers a powerful set of built-in data structures. These structures are designed to be intuitive and easy to use, making Python an excellent choice for both new and experienced programmers. From simple lists to complex dictionaries, Python's data structures are both flexible and robust. Understanding these structures is crucial for writing efficient and effective Python code. By mastering them, you can optimize your programs, making them faster and more reliable. Efficient code not only runs better, but also makes your programs easier to maintain and scale. This essay will delve into 4 key Python data structures: lists, tuples, sets, and dictionaries. Each of these structures has its unique characteristics and use cases, and understanding them will give you a solid foundation in Python programming. We'll explore their characteristics, common operations, and use cases, equipping you with the knowledge to choose the most suitable structure for your programming needs. Whether you're sorting data, managing collections, or mapping relationships, there's a data structure that fits the task perfectly. Whether you're a novice programmer or looking to solidify your understanding, this exploration of Python data structures will provide valuable insights. By the end of this journey, you'll have a deeper appreciation for the power and flexibility these structures offer. From storing collections of items to representing unique elements and mapping relationships between data, these structures form the backbone of countless Python programs. They are the tools that allow you to build complex applications with ease and efficiency. Let's embark on this journey to unravel the power and flexibility of Python data structures. As we dive deeper, you'll see how these fundamental building blocks can transform your coding experience. By mastering these fundamental building blocks, you'll be well on your way to writing more efficient, organized, and Pythonic code. Your programs will not only run smoother, but will also be easier to understand and maintain. So, let's begin our exploration of these essential data structures and unlock their potential in the world of Python programming. With this knowledge, you'll be equipped to tackle any programming challenge with confidence and skill. Lists are the workhorses of Python data structures, providing a versatile way to store collections of items. They are incredibly useful for a wide range of applications, from simple tasks to complex data manipulation. Imagine a list as a container holding an ordered sequence of elements, much like a shopping list or a to-do list in your daily life. This ordered nature allows you to access elements by their position, making it easy to retrieve and manipulate data. In Python, lists are denoted by square brackets with elements separated by commas. This simple syntax makes them easy to create and use. For example, you can create a list containing integers, strings, or even other lists. This flexibility allows you to store a wide variety of data types in a single list. Let's take a closer look at how lists can be used in different scenarios. The beauty of lists lies in their flexibility. They can accommodate elements of different data types, including other lists, making them incredibly powerful for organizing diverse information. This means you can have a list that contains numbers, strings, and even other lists, all in one place. One of the key characteristics of lists is their mutability. This means you can modify a list after creating it. You can add new items, remove existing ones, or change the order of elements. You can add new items, remove existing ones, or change the order of elements. This dynamic nature makes lists well suited for tasks where the data you're working with is subject to change. For instance, you might start with a list of tasks for the day and keep updating it as you complete each task. This dynamic nature makes lists well suited for tasks where the data you're working with is subject to change. Whether you're managing a list of items in a shopping cart, keeping track of user inputs, or handling dynamic data in a web application, lists provide the flexibility you need. Whether you're storing a sequence of numbers, a collection of strings, or a mix of different data types, lists provide a flexible and intuitive way to manage your data in Python. They are particularly useful in scenarios where the data structure needs to be dynamic and adaptable. Their mutability and ability to hold diverse elements make them an indispensable tool in your programming arsenal. Lists are not just a basic data structure, They are a powerful feature that can help you manage and manipulate data efficiently in your Python programs. Tuples, like lists, are used to store collections of items in a specific order. However, they differ from lists in a crucial way. Tuples are immutable. Once you create a tuple, its contents cannot be modified. Think of a tuple as a secure container where the items are fixed in place. In Python, tuples are represented using parentheses. For instance, creates a tuple containing 2 integers and a string. The immutability of tuples might seem restrictive at first, but it offers several advantages. Firstly, tuples are inherently safer for storing data that should not be changed accidentally. For example, if you have a set of coordinates representing a location, using a tuple ensures that the values remain constant throughout your program. Secondly, tuples are generally more memory efficient than lists, especially when dealing with large data sets. Python can optimize memory allocation for tuples because their size and contents are fixed. While tuples might not offer the flexibility of lists in terms of modification, their immutability makes them a valuable asset in situations where data integrity and performance optimization are paramount. Section 4. Sets. Ensuring uniqueness in your data. Sets in Python are all about uniqueness. They are unordered collections of distinct elements, meaning that each element within a set is unique. Duplicates are not allowed. Imagine a set as a bag of marbles where each marble represents a unique element. To create a set in Python, you can use curly braces or the constructor, for example, and both create a set containing the numbers 1, 2, and 3. If you try to add a duplicate element to a set, Python will simply ignore it, maintaining the set's uniqueness property. Sets are particularly useful when you need to eliminate duplicates from a collection of data. For instance, if you have a list of email addresses and want to send a newsletter, using a set ensures that each recipient receives only one copy. Moreover, sets provide efficient ways to perform mathematical set operations such as union, intersection, and difference. These operations allow you to combine, find common elements, or identify differences between sets, making them valuable for tasks involving data analysis and manipulation. Section 5. Dictionaries, key value pairs for efficient data retrieval. Dictionaries in Python are like language dictionaries, where words or keys are associated with their definitions, or values. This analogy helps to understand how dictionaries function in programming. Just as you look up a word to find its meaning, you use a key to find its corresponding value in a Python dictionary. They are unordered collections of key-value pairs, providing an efficient way to store and retrieve data based on a unique identifier. Unlike lists or arrays, dictionaries do not maintain any order, which allows for faster data access and manipulation. In a Python dictionary, each key is unique and maps to a specific value. This uniqueness ensures that data is not duplicated and can be accessed reliably. If you try to use a duplicate key, the dictionary will overwrite the existing value with the new one. Dictionaries are created using curly braces with key-value pairs separated by colons. This syntax is simple yet powerful, allowing for the creation of complex data structures. For example, creates a dictionary where name, age, and city are keys, and their corresponding values are Alice, 30, and New York, respectively. This structure makes it easy to store and retrieve related pieces of information. The power of dictionaries lies in their ability to access values directly using their associated keys. This direct access method is much faster than searching through a list or array. Instead of iterating through an entire collection like a list, you can retrieve a specific value from a dictionary using its key, making data retrieval extremely efficient. This efficiency is particularly useful in applications that require quick lookups and updates. Dictionaries are widely used for storing and managing data with key-value relationships. They are versatile and can be used in various scenarios, from simple data storage to complex data manipulation. From representing user profiles with attributes like name, email, and address, to storing configuration settings for an application, dictionaries provide a flexible and organized way to handle structured data in Python. They are an essential tool for any Python programmer, offering a robust solution for data management and retrieval.